Welcome to Programming in Modern C++. We are in week 2 and we are going to discuss module 8. In the last module, we have introduced the concept of reference with discussion on the parameter passing mechanisms of functions in C++, call by value and call by reference, and also the value return mechanism, that is return by value and return by reference, studied them and saw the advantages of call by reference in certain contexts. And finally, we have made a comparative study of pointers as well as references. In this module, we will talk about default parameters, what they are, and what is function overloading and how that overloading is resolved. It is a new concept again being introduced. So, this is the outline which you will find on the left. So, let us talk about default parameters. Now, for you to realize what is default parameter and why is it important, let us look at this function header. This is from Microsoft Visual Studio, Visual C++, Windows programming. So, this is on left is the declaration of the create window function, and on the right is a typical call that will be made to the create window function. Now, if you look at this, you will find, if you observe carefully, you will find that there are 11 parameters in total in the create window. It is a large function, lot of things to be specified. But out of these, if you see 1, 2, 3, 4 are given default values. Most cases it will be given default value as to where you want to create the window, what should be the width, what should be the height. There is a preferred default that most of the time most programmers would be using. Many a times these 3 are set to null. That is, whether it has a parent, whether it is hanging a menu, or whether you are passing some parameters to the window, or and the H instance, the current instance of the windows on which you are doing this is typically H instance called everywhere. So, given this, as you can see, out of the 11 parameters, 8 parameters most of the time will take the same value for most of the calls. Only primarily these 3 are often what the user would like to set. So, the question is, do I really need to make the user copy paste all these 11 parameters, 8 of them is a big list which hardly differs from one call of the create window to the other, or can I let these default values somewhere be represented in the system, so that if the user does not have to change that default value or does not need to call the function with a value other than the defaulted value, the user does not need to even provide these parameters in the call. That is the whole idea. So, let us see a simple example with one parameter which is default. So, this is how you write it. In the header of the function, after you have written the type and name of the parameter with the initialization symbol, you write a value. The idea for this is clear when you call the function. Now, if you call the function with x, which is initialized to 5, if you call it with x, it is a is taken to be x, which is 5, normal call. but there is something different that you can do. You can call this function without actually passing any parameter, but it needs a parameter, it needs a parameter. So, what it does when you do not pass a parameter, actual parameter, the function takes the default value 10 as given to be the value of a and goes ahead and does the computation. So, it is taken as 10. That is the basic concept of default parameter. Very simple concept and makes life easier in different places. Now, let us little bit go forward. Let us take function with two default parameters, a defaulted for 10, b defaulted for 20, and I can call it with x y 5 and 6. It will take as x 5, a 5, b 6. I can call it with just x, one parameter. Now, if I call it with one parameter, whether it is a or it is b, that is decided from the left hand side. If I pass one parameter, it is the when I pass parameters, it is always taken from the left. So, x is copied to a, so that becomes 5, but b is not given. So, its default value is taken, which is 20. And in the third case, if I do not pass any parameter, both a and b takes their default values. So, it always goes from the left, and as many parameters as are provided will take the values of the actual parameters, remaining must be default and they will take their default values. That is the whole idea of the default parameter. So, it allows programmers to assign default values to the function parameters, that is the basic idea. It is recommended that you provide the default value while you prototype the function. Normally what is, we write a prototype and later on we put the function body. So, we are actually writing the function header twice, once during prototype and once during definition. So, what is recommended is put the default values while you prototype, not during the definition, because the prototype is likely to be included in many other files as well, and therefore, it will be clear as to what the default values are. Default parameters are required while calling function with fewer arguments or without any argument at all. You have already seen that. As a design, you should arrange your parameters in a way so that the default values are used for less used parameter. If you use a default value for a frequently used parameter whose value can be different, then every time you will have to provide that anyway, right? And default arguments can be expressions as well, right. So, these are some of the basic stuff. Now, there are some restrictions on the default. The restriction is, since we are considering in the call, we are considering the parameters from left, as soon as you default one parameter, all parameters to its right must always be defaulted. So, you have non-default parameters, then a parameter which is default and onwards everything has to be default parameter. So, the entire sequence of parameters from left to right will be sequence of non-default parameters followed by sequence of default parameters. That will always have to be the pattern, because otherwise there is no way to resolve to know which parameter is what, because in C++ we always associate parameters by their position, not by their name, right. So, if you look at that, you can see here, I have defaulted this, but I have not defaulted this. This is not allowed, right, because if I call it with two parameters, because I at least need two parameters, int and the char star, to call this, because only one is defaulted. But if I give two parameters, the compiler will also always take them to be these two parameters, because it is going from left, right. So, that is the basic protocol you have to follow. The second is, when you provide default values, you cannot multiply provide default values in two different places or in two different signatures, even if the values are same. Right? So, you can see here that I have two functions header of G, int double cat star, int is non-default, that is fine. In this I have made double defaulted as 0, in this I have made double defaulted as 1. This is not allowed. In fact, this also is not allowed. It will say that you have already provided a default value, you cannot redefine that. Right? So, that will not be accepted in the compilation, because you do not know which of these headers will be used in compiling which invocation of the function in what file, and therefore, there may be confusion. Right? And naturally, while you call, all non-default parameters must be provided, and only the default parameters can be skipped. So, in this context, if I call function G without a parameter, it is an error, because G always has the first parameter. I mean, I am talking in reference to this particular signature of G, which is the valid one, but I can call it with one parameter, which will be int, two parameters, int and double, three parameters, int, double and cat star. Right? So, this is a basic rule of default parameters. Another, which is kind of I should say a programming practice, is this is not a language specification strictly, but the programming practice is you always provide the default parameters in a header file. Right. So, here I have three overloaded functions, we will see what overloads mean, or I can have this signature of G with all three parameters defaulted, have them in the header file, and then I include this header file to define the function. And in this definition, I am not providing the default values. Having it in the header helps, because any function, any file which includes the header for calling the function will get to know what the default values are, because if we were given it here, then this source file may not be available to a user who is wanting to use the function, right, because this is a different file. Right. Now, since there are three parameters, all of which are defaulted, there are four ways to call this function, which is you must have understood by now very clearly. Okay. I loosely talked about, I said these functions are overloaded. Let us understand what the function overloading is. Again, the context. The context is, suppose there are different situations where conceptually I am trying to do the same thing or very similar thing, but my data types are different, my algorithms are different, and therefore, they have to be different functions. If I want to do this in C, each such function will have to get a unique name. Right? So, let us say I am talking about matrix multiplication, and I have three data types. One is a square matrix, one is a row vector, and one is a column vector. So, if I have these three data types, then there are five possible ways I might multiply. I can multiply a matrix with a matrix, matrix with a column vector, a row vector with a matrix, a column vector with a row vector, which will give me a matrix, or a row vector with a column vector, which is basically dot product, will give me a value. Right? So, these are, you can check the types of parameters being passed. Everything is here, these are passed by value, this is by address, because you want the output to come in, the typical C style of stuff. But all of them are multiplying, kind of using the same matrix multiplication rule, but because their data types are different, you have to give them different names. So, as a programmer who is trying to use this, the programmer will have to remember, okay, multiplying matrix by vector column is multiply underscore m underscore V c, very cumbersome, right? And we will see a lot of other problems also arise because of this. So, what I would prefer is I have the same situation, the different data types, different algorithms, but I would like to call all of them by the same name. This is overloading. One name, multiple meaning. One name, multiple meaning. So, you are overloading. If you consider the meaning to be a load on the name, then you are overloading it, giving multiple of them, which C does not allow. C++ allows that, and since we are in C++, now your inputs are all in terms of const reference, whereas your output is in terms of non-const reference, because certainly you do not want to copy matrices and do not want the input matrices to change because of the algorithm. And then now the question that you will have is, naturally 5 functions will have 5 different codes. How will, from in C we always knew that the function name is unique globally. So, from the name the system knows which function, what is the body that should be used. Here how would you know that all of them have the same types? All of them have the same name. So, that is where the parameter types become important. So, if you let us say if you look at say this second function, multiply M1 CV RCV. M1 is of type mat, CV is of type column vector, vec_col, RCV is also of type column vector. So, I will look for, out of the 5, I will look for that particular overloaded function which matches this type. The first one is mat, which means it could be any of these two. Second one is vec_col, which means it has to be this. I already have got a unique function, and the third one has to match this, otherwise it is an error. And you can see that between any two functions, if you consider the types of parameters from left to right, they are distinct. There is something which is distinct. For example, just for better understanding, let us take say the fourth one, CV, RV, RM. CV is vec_col. So, this does not help, because this immediately gets you here. There is only one function which has first parameter as vec_col. So, let us look at something which can be more confusing. So, let us look at 5. Let us look at 5. The first is RV. RV is vec_row. If it is vec_row, then it can be either this function or this function, whose first parameter is vec_row. Then the second parameter is CV, which is vec_col. So, in this the second parameter is mat, so it cannot be. So, it has to be this. And the third parameter is R, which is int, and it matches. So, it is a fifth function. So, what you are doing now is in C, globally by the name you are deciding the function, we say this is binding. With the name and the actual body of the function, we say this is a binding. The binding was happening just by the name. Now, the binding is happening by the name as well as the types of parameters. This is known as static polymorphism or function overloading. Why static polymorphism? Polymorphism means poly means many, morph means change, forms. So, polymorphism refers to the fact that when you have something which is in multiple forms, but common. So, these are polymorphic. And why is it static? Because the compiler itself can find out what is the right function to bind to. Right? So, that is a basic point you make here. Okay. So, here quickly we will have examples. So, I have two functions, both of which are double, both of which has 2 parameters, but one has 2 ints and one has 2 doubles. So, when I call it with add x y, which are both int, this function will be called the first one. When I do both with double, the second function will be called by the type we will be able to resolve. Here I have an example of area function where one has 2 parameters and one has 1 parameter. So, naturally, if one is basically computing for rectangle, other is for square. So, once I do x y, it will call the first function. If I do this, it will bind to the second function. That is the whole idea of the polymorphic static polymorphism or function overloading. But however, the resolution must be possible by the parameters only. You cannot resolve based on the return type. 2 functions which are indistinguishable, 2 functions having the same name of course, which are indistinguishable by their parameter types cannot be decided by their return type. Very simply, because when you call the function, you only pass the parameters. There is no way to tell what kind of return value you are expecting. It is whatever you get, right. So, that is not possible. So, here in this example, we have just illustrated that between these 2 area functions, the resolution is not possible. So, if I call it like this or I call it like this, whether I am taking the value in int or I am taking the value in double is not something. So, this part is not something which the system knows, because I may not just copy the value, I can just call the function also, that is valid, right. So, but there the parameter types are identical. So, this is not permitted. So, the summary of the rule, same function name, several definitions, different number of formal parameters or the same number of formal parameters with different types, and the selection is based on the number of the actual parameters. And if there are multiple such, like I just showed in case of matrix multiplication, there are 5, and how we are able to choose the right one for binding from the 5. So, that process is the process of resolving how you decide on the resolution of the actual function that needs to be bound. So, this is known as overload resolution. Now, overload resolution goes through certain phases. First is you identify a set of candidate functions, then you identify the set of viable functions from the candidate functions, and finally, you choose the best viable function according to this set of steps. What is best by exact match, if not by promotion, if not by standard type conversion, if not by user defined type conversion. Let us go through that. So, what is exact match? When 2 parameters exactly match. Now, they will exactly match if they are exactly identical type, of course, but certain things are considered loosely as exact match, like L value to R value conversion is exact match. If you say variable A, then in the context of the left hand side it is an L value address, and the context of the right hand side it is an R value. So, any variable can be used by taking its value, that is a match. Arrays and pointers conversion are an exact match. So, I can define an array, I can have a function which takes a pointer of type integer and pass an integer array to that. I can have a function pointer and pass a function to that without making it a pointer. I can convert pointers only to constant pointer. These are all exact match conversions that can be done. Now, the second that I can do is promotion. Promotion is when I have a value of a smaller type, smaller in terms of size, and it's typically promotion typically applies to integral types only, then I can always represent it with a bigger type. So, I have a char, I can represent it by short int, or I have a int, I can represent it by long. I have a float, I can represent it by double, and so on, right, which is quite obvious. Then there are certain conversions which are possible. For example, I can convert between integral types with or without the qualifier of sign. I can convert between floating point types, float being converted to double, double being converted to long double, and so on. So, when I do that, I can be from less precise like float to more precise like double, that will have no issue. But if I want to do the reverse, then not always it may be possible, because the more precise will have a bigger chunk of possible numbers. I can convert pointers, I can do conversion of bool integer. So, an example to illustrate how the resolution will happen. Let us say I have a function called f 5.6. So, it takes one parameter, 5.6 is a literal of double type. So, it expects a double type, right? And these are the functions available to you. So, first what you do, you create the set of candidate functions, which are functions having the same name. So, f, 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 these 4 are candidate functions f 2, f 3, f 6, f 8. Out of these candidate functions, you decide on the set of viable functions. Viable functions are those which match the number of parameters, that has to be possible. So, here there is one parameter. So, this goes out, this takes 0 parameters. This also goes out because it needs 2 parameters. This will be valid, it has 1 parameter. This will also be valid because though it takes 2 parameters, the second parameter can be defaulted. So, I can call it with 1 parameter. So, what remains from this is f 3 and f 6. So, if I want to call, then actually 5.6, the actual parameter value will have to go to here for f 6 and have to go to here for f 3. The first one is exact match, double to double, and the second one is floating point to integer conversion. So, what did I say? Exact match, promotion, conversion, user defined conversion. So, the topmost, the first is exact match. So, we have got an exact match here. Therefore, f 6 is my resolution. You can try it out by trying to run this program. You will see that it binds with this function. Whatever is there in that function is what will be executed. Right? Now, there could be ambiguity also. For example, here as you can see that 3 candidate functions, and I am calling it with 2 parameters in call 1. So, there are 2 viable functions and there is no way to resolve them because they have the same types. Similarly, if I call it in call 2 with 1 parameter, there also there are 2 viable functions, function 1 and function 3. So, I cannot resolve them. So, in such cases the compiler will say that I am confused and I cannot resolve this. Now, naturally you can have default parameters also with function overloading, or rather the default parameter mechanism itself is a function overloading. Because if you look at this, then there are 3 possible ways to call it, which means that if you had 3 different overloaded functions, you would have had the same behavior, right. So, default parameter is a semantically different entity, but it actually tells us or tells the compiler that you are doing an overloading in terms of the number of parameters and their types. Right. So, it is the default parameters are handled in the same way as the function overloading is handled. Now, you can have a mix of them as well. For example, you can have function overloading with default parameters like in what we have here. It is overloaded function area, this has one default parameter, the other has none. So, there are multiple ways. So, what is area x? X is int, it is one parameter. So, it has to be the first function and it matches. So, this is an easy case, binds this. What is area x y? 2 parameters. So, both functions are actually viable, but the first one has the exact match. So, this is what we get. If we do area Z W, Z is double, W is double, sorry, Z U, Z is double, W U also is double. So, the second function out of the 2 viable functions, the second function has a perfect match, as an exact match. But suppose you call it with area Z, where Z is double, then naturally there is only one viable function, which is the first one, and therefore, it will still be able to bind, but it will go through a conversion from double to int. Okay. Now, suppose if you call it with area Z y, where Z is double and y is int, double and int. 2 parameters, so both of them are viable. And you see, if you want to find the exact match in the first, then the first parameter needs a conversion, second parameter is an exact match. If you take the second, the first parameter is a match, exact match, second parameter needs a conversion. So, the weightage of these two are same to the compiler. So, the compiler will again get confused and say that I cannot resolve, and we cannot have this area Z y, this invocation is unresolvable as a overloaded function. Similarly, you will have to make sure that when you have default parameters and overloading, default parameters and overloading together must be resolvable. For example, here a function call without parameter is not resolvable, because between the first and the second it can be either of them, whereas with 1 parameter or 2 parameters this is resolvable. Right. So, to summarize, we have introduced the notion of default parameters and discussed several examples, and particularly the necessity of function overloading and how does it bring in the first major type of polymorphism known as a static polymorphism, which will play a very critical role in different aspects of modern C++ as we go forward. Thank you very much for your attention, and we will meet in the next module.